Now I'm going to give a Unit 8 Basic Polynomial summary. We begin this unit by identifying the different parts of the polynomial. Okay? We wrote in our definition that polynomial is a sum of a bunch of monomials. As you can see here, the term x cubed is a monomial. Then you see the next word is coefficient. Coefficient is the number preceding the variable, or the number that is in front of our variable. This little exponent 2 that we see here is called the degree of the monomial. It's essentially the exponent part of your term. And then we end with this exponent of 3, which we call degree of a polynomial. So degree of polynomial is the highest exponent among all of the monomials of your polynomial. After we have identified the different parts of a polynomial, we look at how to factor the GCF, or the greatest common factor. So, first example, factor 4x squared plus 8x using the greatest common factor. We first need to determine the common factors of 4x squared and 8x. So as you can see here, 4 is the largest number, okay, that goes into 4 and 8. And then x, okay, they both have x in common, and we use the one that has the smallest exponent to be our common factor. So we are going to take the GCF 4x outside of the parentheses, and then we fill the remaining fill in the parentheses with the remaining two terms. So you look at 4x, okay, times x, that's going to give us the original 4x squared, and then 4x times 2 will give us the original 8x. So that is how you factor using the GCF. Following that, we look at difference of squares. So we start by multiplying 2x plus 5 and 2x minus 5. When we did that, we saw that we end up canceling the middle terms, as you can see here. So we only have 4x squared minus 25. We call this a difference of squares, and that the quantity of 2x plus 5 times the quantity of x minus 5 factors of different squares. We looked at the different characteristics of difference of squares. We notice all three of these expressions have the lead coefficient to be perfect square. 4 is a perfect square. It means that you can find a whole number, multiply itself to give us 4. 36 is a perfect square. 49 is a perfect square. We also notice that the exponent is an even number. X squared, okay, 2 is an even number. X to the 8, 8 is an even number. X to the 12, 12 is an even number. We also notice that all three of these expressions have subtraction. And last but not least, our last term is also a perfect square. So 25, 9, and 81, these are all perfect squares. So if you want to be able to identify difference of squares, you need to check these 4 things off. After that, we define what an identity is. So we have 4x squared minus 25, and when we factor that out, we have 2x plus 5, okay, times 2x minus 5. This is an example of an identity because the two sides of the equation are equivalent. Following the lesson of different squares, we did a little activity with completing a table. It took us a while, but we figured that if we add, okay, the first two numbers, we will get the third column. And if we multiply the first two numbers, we will get the product. So this is an introduction to factoring monic trinomial. We'll define monic trinomial is a polynomial that has three terms with one as its leading coefficient. So x squared minus 4x plus 4 is an example of a monic trinomial. X squared plus 6x plus 9, that is also an example of monic trinomial. 3x squared minus 4x plus 10 is non-monic because the leading coefficient is not 1. So, we are going to look at how to factor a monic trinomial. Okay. Now, at first glance, this doesn't look like it's a monic trinomial because the leading coefficient is not 1. So that's kind of give us a clue that we need to do something, and that could be finding the GCF. So we look at these three terms, we will see that 15x is the GCF, so we factor this out. There are many ways of finding the remaining terms inside the parentheses. One way is you take the original expression and you divide it by your GCF. So if you divide 15x cubed by 15x, okay, you have x squared. If you take 15x squared divided by 15x, you have x. And if you take 90x divided by 15x, you get 6. After that, you want to see if you have a difference of squares or monic trinomial. And since we're talking about trinomial, it looks like we are going to do the sum and product. So remember, the middle term is your sum, the last term is your product. So what we need to do is we need to find two numbers that multiply to give us -6 and add to give us -1. What you want to do is you kind of want to ignore the negative for now, and you just want to list out factors of 6. Luckily, there are only two pairs of factors of 6. You have 1, 6, 2, and 3. Then you kind of look here. It says that you have to multiply to give you a -6. That means one of your numbers has to be negative. And then you look here, we need to add those two numbers and give us a -1. It means that you will begin with more negative. So you know on this side, your numbers will be negative. So you kind of test it out. -6 plus 1, will that give us -1? No, it does not. So that means that the second pair will be the one that we want. -3 and then +2. So let's check. 2 times -3 does give us -6, and 2 plus -3 gives us -1. So now, just to finish, we need to write x, one factor of x here, another factor of x there, and you fill in the +2 from the +2 that we found, and the -3 from the -3 that we found. And of course, we need to include the GCF. So that is how you factor a monic trinomial. But this one is a special case because you have to factor the GCF first. So what's the point of factoring and so forth? Well, the point is that so we can solve quadratic equations. A quadratic is a polynomial with degree of 2. X squared plus 4 is an example of quadratic. X squared plus 2x minus 3 is another example of quadratic. So the first method that we looked at is solving by taking square roots. Example, solve x squared equals 25. Well, if we want to get rid of this exponent, we need to take the square root, okay, on both sides. So we have x is equal to +5 or -5. Let's look at another example. The quantity of a plus 3 squared equals 36. When you take the square root of both sides, So you have a plus 6 is equal to 6, or, excuse me, a plus 3 is equal to 6, or a plus 3 is equal to negative 6. Then you write them as two separate equations. You have a plus 3 is equal to 6, or a plus 3 is equal to negative 6. Then using basic move of algebras, you'll be able to solve and see that a is equal to 3, or a is equal to negative 9. The second method is using factoring in ZPP. So we had to figure out what is ZPP. So we look at a simple example. If we had a times b is equal to 0, then we could say that a is equal to 0 or b is equal to 0. So that is essentially the idea of ZPP, or zero product property. If you have a times b is equal to 0, then a could equal to 0 or b is equal to 0. Let's look at this example. You have 7x times the quantity of x minus 5. That means your 7x has to equal to 0, or your x minus 5 is equal to 0. Now, once you have these two equations, you can use basic moves of algebra and solve for x. So our two solutions for this equation is x equal to 0 or x is equal to 5. Okay. Now, here we have our final example. We need to solve 9x cubed minus 25x equals 0. Remember, we're using factoring in zero product property. Ultimate goal is we want to have our expression factor so we can use ZPP. So you need to follow these three steps. First, determine if you have a GCF. Here, okay, our GCF is x. That's the only thing we can factor out. When we factor out x, we will have 9x squared minus 25. Then we recognize that inside our parentheses, we have either difference of squares or trinomial. And we have the subtraction, perfect squares, and even exponent, so we have difference of squares. Remember how to factor difference of squares? You need to have two sets of parentheses, one positive, one negative, or one plus and one minus, and then you take the square root of 9x squared, you get 3x, so you write in this set of parentheses, and you write in the other set of parentheses. Then you take the square root of 25, you get 5, one factor of 5 here, one factor of 5 there. Then the last step is you use ZPP. So you need to set each part of the equation equal to 0. So you have x is equal to 0, 3x minus 5 equals 0, or 3x plus 5 equals 0. Again, using basic moves of algebra, solve for x so that you will end up with 3 solutions. X equal to 0, x equal to 5/3, or x is equal to negative 5/3. Okay, I hope you found that summary helpful to help you prepare for your Unit 8 tests. Again, thank you for watching.